And welcome back, students, as we continue our journey through the LC3's ISA. So part 2, we're going to pick right up with data movement instructions. All right, so our next command is the load command, which reads data from the memory to the register. And there's particularly 3 ones to talk about. There's LD, which is the program counter relative mode, LDR, which is base plus offset mode, and LDI, which is indirect mode. Then, of course, there's the store, which writes data from your register to the memory. So this is how you actually, it's like if you want to actually store something out of the register and put it actually into memory, this is how you do it. There's the ST, which is, of course, PC relative, STR, which is base plus offset, and STI, which is indirect. And lastly, there's the load effective address, which computes address and saves in register. You have the LEA, which is the immediate mode and does not access memory. Alright, so let's look at the first one here, which is PC relative addressing mode. Alright, this is where I want to specify the address directly in the instruction. But an address is 16 bits, and so is an instruction. So we have a little bit of dilemma there. So after subtracting 4 bits for an opcode and 3 bits for a register, we have 9 bits available for an address. So the solution is to use the 9 bits as a signed offset for the current program counter. So 9 bits technically can go from -256 all the way up to 255. So therefore we can form any address such that the program counter minus 256 is less than x, which is less than the program counter plus 255. Now the important thing to remember is that the program counter is incremented as part of the fetch phase. So it does increase as we go through those different phases, as we're cycling through it again and again. This is done before the evaluate address stage. So if you're going to do this kind of thing, you have to do it before that. So here's the LD, or the PC relative. If you're following this, you have your instruction register right here. You have the program counter right here. Both of those go and feed right in here. It eventually feeds down to the MAR, that loads into memory. From memory, it goes into the MDR. And from MDR, it's going into your register file, which is your destination. Alright, from there, let's take a look at store, which is also PC relative. So this is the ST store command. And you can see with this one, it's very, very similar. Alright, the biggest difference here is that you'll notice LD is 0010, ST is 0011. So that's the big difference between the two of these, because otherwise you can see the only real difference is that this one is giving you a destination. This one's giving you a source, because now, instead of it going from memory to register, going from register to memory. So it's a slightly different there. Now, indirect addressing mode is with PC relative mode. You may have noticed you can only address data within 256 words of instruction. But what about the rest of the memory that's out there? So, solution number 1 is to read the address from memory location, should say then load, that's a typo there, and store to the address. The first address is generated from PC and IR, just like PC relative addressing. Then the content of the address is used as a target for load store. And if we take a look at our indirect processing, we have our instruction register passing in here. We have our program counter passing in. Right, those of course pass down to the MAR here. MAR then is feeding to memory. Right, from memory, the next spot that it is going to go is that you can see from here we have programs feeding into the MDR. And after that, we have our nice big jump out here, which goes into destination file. Because you see, MDR feeds back to the MAR, feeds back to memory. Memory cycles back around to MDR, which of course ends up in the destination file. And if you look here, now our opcode this time is 1010. Right. And here's our store indirect. Now you can see with this one, again, it's very similar to kind of what we saw before. It's like this time now, the final step for everything is not to end in the registry. It now is going to go to memory. All right. Next one, of course, is base plus offset addressing mode. With PC relative mode. Again, we can only address data within 256 of instructions. Again, we have to ask, what about the rest of memory? So we are presented one solution. This is a second solution. And the solution is we can use a register to generate a full 16-bit address. We use 4 bits for the opcode, 3 for the source destination register, and 3 bits for the base register. The remaining 6 bits are used as assigned offset. Offset is assigned extended before adding to base register. And so if I look at my base plus offset, you can see this is kind of cleaned up a little bit. We have our instruction register right here feeding in, as well as our base coming out of our register file. Those are feeding into the MAR, which then of course feeds into memory. Memory then gives the command back to MDR, which then will feed that over to the register. And similarly with STR, which is again base plus offset, you can see it's exactly the same thing, except now, again, we're going and taking our source file here from register, and everything's ending up over here. Memory. All right, let's talk next about load effective address. All right, load effective address computes addresses like program counter relative or program counter plus the assigned offset and stores the result into a register. Now note, the address is stored in the register, not the contents of the memory location. It's very important to know that. And let's take a look at how that looks. And again, here's our opcode 1110, and here's our destination. So we have the program counter right here now is feeding down. All right, and we have our instruction register. And then what we do with those two pieces of information, we're taking and we're feeding them right into the destination file. And that concludes our notes, folks. Until next time.